Hello, my name is Mudit Jain. I am an architect with more than 34 years of professional experience in design, project management, and construction coordination. Over the past few years, I have been focusing on applying BIM technology and automation to solve practical problems encountered in real construction projects. Through my initiative BIM-Thinker, I explore how BIM can move beyond modeling and become a decision support and data-driven platform for the construction industry. One of the recurring challenges in BIM workflows is obtaining reliable RCC quantities directly from the model in formats aligned with industry measurement practices. While BIM schedules provide quantities, they often do not address requirements such as level-wise quantities, deduction logic, or precedence of intersecting structural elements. To address these issues, I developed a quantity automation framework that automates RCC quantity computation in a structured and verifiable way. This automation framework currently processes the following structural elements: columns, beams, slabs, RCC walls, RCC foundations. The computed quantities are exported to Excel measurement sheets, stored inside the model through shared parameters, and verified visually using automatically generated 3D views and schedules. So in this short demonstration, let's explore how this automation works and how it helps bridge the gap between BIM model data and real-world quantity measurement practices. Visual Studio Code. Overview. I will first briefly show the code structure of the automation framework. The project is organized into a main folder called RCC Quantity, which contains separate subfolders for each structural element type. For example, columns module, beams module, slabs module, RCC walls module, foundation module. Each module contains dedicated classes responsible for element collection from the BIM model, geometry processing, intersection detection, quantity calculations, writing results to shared parameters, exporting measurement data to Excel. The execute method is intentionally kept lightweight. It mainly orchestrates the workflow by calling specialized classes responsible for each operation. This modular approach provides several advantages: easier debugging and maintenance, independent development of each element logic, future extensibility to additional structural components. The Excel export functionality is implemented, allowing the program to generate multiple worksheets automatically. Let us now switch to the BIM model before executing the automation framework. In this model, you can see typical structural elements: columns, beams, slabs, RCC walls, foundations. I have also added shared parameters to each element category, but currently they are blank because the automation framework has not yet been executed. These shared parameters will eventually store information such as net concrete volume, level-wise quantities, opening deductions, intersection deductions, intersecting element types. At this stage, the model represents a typical structural BIM model before quantity computation. Now I will run the RCC quantity automation framework. Once executed, several automated processes occur. 1. Element geometry is analyzed. 2. Intersections between structural elements are detected. 3. Precedence rules are applied. 4. Quantities are computed. 5. Shared parameters are populated. 6. 3D views are automatically created. A key rule implemented in this automation framework relates to intersection precedence. For example, at intersections between columns and other RCC elements, the automation framework assumes that columns typically use a higher grade of concrete. Therefore, the overlapping volume is assigned to columns and deducted from the intersecting elements. This prevents duplication of quantities and aligns with many industry measurement practices. The automation framework also handles several geometric conditions, including split levels, cantilevered walls, light well columns, slab openings, beam intersections. All calculations are performed in such a way that each volume is counted only once. Automated 3D views with visual filters. Another helpful feature of this tool is the automatic creation of visual verification views. For each structural element category, the automation framework generates a dedicated 3D view, such as columns view, beams view, slabs view, RCC walls view, foundation view. In each view, only relevant structural elements are visible. All other categories are hidden automatically. Additionally, color filters are applied to show computation status. The color scheme works like a traffic light system. Green indicates successful quantity computation. Red indicates elements where computation failed or requires review. Additional colors may be used to distinguish subcategories of elements. This allows engineers and BIM coordinators to quickly identify problematic elements directly in the model. Schedules generated from shared parameters. After computation, the shared parameters inside each element are populated with detailed information. Examples include net RCC quantity, level-wise quantity allocation, deduction due to openings, deduction due to intersections. One interesting feature is that the shared parameters also display calculation formulas for transparency. For example, if we look at a beam, one of the shared parameters may display the actual beam length calculation. The parameter clearly shows how the value is derived. For instance, it may read something like actual beam length equals 12.0 minus the sum of 2.3, 2.1 and 0.8. This makes the deduction process completely transparent. This allows users to clearly understand how the final quantity was derived. Dedicated BIM schedules are also automatically generated for each element category. These schedules directly read the shared parameters and therefore reflect the same computed quantities. Comparison between BIM schedules and Excel. Now let us look at the Excel output generated by the automation framework. All computed quantities are exported into a single Excel workbook, which contains separate worksheets for columns, beams, slabs, RCC walls, foundations. Each worksheet contains a measurement sheet listing element level quantities. For large data sets, the automation framework also generates a summary sheet, which aggregates quantities and provides hyperlinks to the detailed measurement sheets. This allows engineers or quantity surveyors to quickly navigate between summary data and detailed measurement entries. At this stage, we can compare the outputs from two perspectives: BIM schedules inside the model, Excel measurement sheets generated by the automation framework. It is important to note that these two outputs are not intended to be identical because their formats serve different purposes. BIM schedules primarily help us link quantities directly to model elements, enabling quick verification within the BIM environment. On the other hand, the Excel sheets present the data in a measurement format that aligns more closely with industry quantity takeoff practices. In this way, the BIM schedules and the Excel sheets complement each other. Together, they fulfill practical industry requirements while still allowing quantities to be traced back to individual BIM elements for verification and auditing. Finally, we return to the model and verify the results visually. Using the 3D filtered views and schedules, we can quickly check whether any element has been missed, whether any element shows computation errors, whether quantities align with expectations. Because the data is stored both in Excel and inside the model, the workflow supports transparent auditing and verification. This RCC Quantity Automation Framework demonstrates how custom BIM tools can bridge the gap between raw model data and real-world construction measurement requirements. by combining automated geometry analysis, structured quantity computation, visual verification tools, and structured Excel reporting. The workflow significantly improves accuracy, traceability, and efficiency in quantity takeoffs.
If you like the video, please like, subscribe the video and channel. This will encourage me more. Your comments will help in refining the content and defining the intent.